This tutorial is for mile marker 3, practice 1, question 4. In question 4, for the first thing we want to do is identify what strategy we're going to use to solve this problem. So you may notice that we're given one of the sides of the triangle, one of the angles, and we're asked to find another side. So that should be our biggest clue that we are going to use a trig function to solve this. So I'm just going to go ahead and code this by writing the word trig. So let's review a couple things about our trig functions. So when I say trig, I'm referring to sine, cosine, or tangent. And we've talked about that sine is the ratio of the opposite side to the hypotenuse, cosine the adjacent to the hypotenuse, and tangent is the ratio of the opposite to the adjacent sides. So when I say the sine or the cosine, I'd be saying the sine of 56 degrees or the cosine of 56 degrees. So let's just review real quickly, how to decide if a side is the opposite or the adjacent side. So if you look at the triangle I just drew, or just pulled down, I should say, into view, let's say that this is the angle that we're solving for. We know the hypotenuse never changes. The hypotenuse is by definition always across from the right angle. So everything else here is relative to this angle. So the side that is opposite this angle is this bottom side. The side that is adjacent to the angle is the side that actually connects to the vertex of that angle right there. So this is our adjacent side. All right, but that's just if that's the angle we're looking at. Let's imagine for a second that we're looking instead at this angle. Our hypotenuse wouldn't change, but this time this would be our adjacent side and this would be our opposite side. So a common mistake people make here is just not considering which side is the opposite and which is the adjacent. So now if we go to our picture and we look at what we're given the hypotenuse and we're solving for the adjacent side. We don't have or need any information about the opposite side. So that should tell us that we're going to use cosine for this problem. All right, so the cosine of 56 degrees, is equal to, and we said it's always going to be adjacent side over hypotenuse. So x over 47. All right, so that's our statement, but I can't plug it into the calculator just that way. I need to figure out, I need to really just isolate x in this statement. So in my opinion, the easiest thing to do is let's just stick a 1 under this cosine 56. And if our cross products are 1 and x somewhere, we can cross multiply. And if they're not, we would want to really manipulate this proportion to get those cross products. But if I look, I observe 1 times x is one of our cross products, and the other is 47 times the cosine of 56. So we're just going to go ahead and cross multiply. So when I do that, I'm going to write the 47 in front. So I could say 47 times the cosine of 56 equals, and that's going to be 1 times x, which I know is just x. All right, now this is a statement that we can plug into our graphing calculator. And when we do, the calculator will do all that difficult math for us, and we're going to get a long decimal that we will round to 26 and 282 thousandths. That's our approximation of x. So again, make sure that you are rounding to the 3rd decimal place, which means you really have to look at the 4th decimal to decide if you're going to truncate or round up.